Hi friends, welcome back. Today we are going to solve one important coding question that I recently solved. This problem actually there is no as such a formal statement to solve this problem. I'm just going to explain what the problem is that got asked, and we'll go through the two different approaches. We are also going to discuss one very important coding technique. So if you are preparing for any coding rounds of interviews, make sure you watch this video until the end because you are going to learn a lot from this video. Before we start looking into this problem details, I want to mention that this channel is to help people in their coding and Java interviews. On this channel, there are more than 400 different varieties of solved coding problems explained with whiteboarding sessions, examples and Java code. Um, Many of those questions are pretty standard coding interview questions previously asked by big tech companies that includes Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Netflix, Uber, LinkedIn, and many other companies. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, this channel can definitely help you in your interview preparation process. So please subscribe to this channel now. Um, Also, whenever we solve any important coding problems like this one, we create videos so that we can discuss our approaches, talk more about how to solve different varieties of problems using different data structures and algorithms on this channel. So make sure you click on the bell notification icon so you won't miss any important postings from this channel. So let's start with this problem. So the problem says that how many cars pass through the sensor in 5 consecutive seconds. So there is a highway like this. Basically I just created one pictorial representation and there is a sensor actually, right? This kind of this blue is a sensor. So what that sensor does is it actually monitors the cars that are passed actually in 1 second, right? For example, you can see these are 3 cars that passed in 1 second here, right? In the next second these 4 cars will be passed through the sensor, right? So it just captures how many cars are passing every second. That's what that sensor does, and this is the data that sensor is providing. It's in array, right? So these many cars are passing actually in 1 second. For example, in the first second only 1 car passed, in the second 4 cars passed, in the third second 2 cars passed, in the fourth second 12 cars passed, right? So maximum 20 cars can pass because it's a, you can imagine it's a 20-lane highway, right? So 20 cars maximum can pass at 1 second, right? So as you can see, for example, here is 20 cars passed. So this is the data that sensor is providing us in the form of array. What that array is telling us is how many cars are passing in that second, right? So what they are asking us to do in this problem is we want to find out maximum number of cars that have passed through this sensor in consecutive 5 seconds, right? This is important, right? 5 consecutive seconds we want to find out. So if you just look at this, so I think the problem statement is pretty clear. So this data that array has given us is number of cars that have passed through the sensor, correct? And we want to find out number of cars in 5 consecutive seconds, maximum number of cars that have passed, right? So I will explain you. So we'll go to this example here. So this is the same data that I just copied here, this array and k. So k is actually a variable value, right? K is basically they can also ask us, right now we are discussing that it's 5 seconds, but they can ask us 10 seconds or 2 seconds also. So it is a variable, it's a changing variable, right? So let's see how we can solve the problem, right? So first basic approach we can do actually is just a brute force way if we want to solve this problem, right? How we will solve it? We want to find out 5 consecutive seconds, right? 5 seconds. So what we can do to solve this problem, the brute force way, how the brute force will go is we will always take the 5 seconds, right? So first 5 seconds we can take like this. So these are our first 5 seconds, right? So if I calculate the sum, how much it is? 1 plus 4 is 5 plus 2 is 7, 19, and 19 plus 8 is 27, right? So I captured the sum here, right? 27. I'll keep track of what maximum sum we have seen basically, right? Maximum sum we have seen in this, right? So now we will keep going. So now next time I will capture this next 5 seconds basically, right? I'll go through this array again, next 5 seconds I'll get this much. How much it is? 32, right? If you calculate this total, it is 32. So I just put 32 here, right? Now next second I will go the next 5-second window, right? So this is the next 5-second window. This is the brute force approach, right? We can go every 5-second time frame. We will capture all these cars, right? So 2 plus 12 is 14 plus 8 is 22 plus 6 28 plus 10 is 38, right? So 38. So like this we can go until end, and this is our last 5 seconds, correct? So this is the last 5 seconds. So how much it is? 14 plus 4 is 18 plus 8 is 26 plus 6 is 32. So this is 32, right? So in this whole thing we have seen that 54 is the maximum. Basically 54 is the maximum that we have seen in 5 consecutive seconds, correct? So 5 consecutive seconds. So where is that 54? So these are that 5 seconds where you will see 54, correct? So if you calculate this, 20 plus 10 is 30 plus 4 is 34 plus 8 is 42 plus 12, right? 42 plus 12 is 54. So this is the maximum in 5 seconds. So we have to return 54 as the answer basically, right? So this is our brute force way. So if this array has n number of elements, and if we are looking this 5 consecutive seconds we are looking right now. So let's say 5 is basically k, right? So basically what is the time complexity for this algorithm? N into k, right? N times k we are doing this, right? As I shown you in this example, first this one, then this one, then this one, like this. We'll keep calculating that 5 seconds time frame, k number of time, sorry, n number of times we will do that, right? So it is n into k. So that is the time complexity for this algorithmic approach, right? So this is a brute force, right? So I'll show you the brute force approach first. And this one will not be a very desirable solution, right? Because if n, what if n is a very big number, right? What if n is equal to 1 million, right? 1 million numbers, then this will not work, right? It will just time out basically, because it's 1 million times 5, let's say, right? So 5 million times we are doing this, so it is just going to time out basically, right? In that case, so this solution will only work for small numbers, right? Like as I shown you here, it will work for small numbers. But if the n, which is the length of this array, if it is very big like 1 million or 10 million, then this will not work basically, right? So we have to find out little better solution than this, right? So this is the, our first solution is basically brute force solution, right? So we already I shown you what is the brute force solution, along with how the sums will be calculated for each 5 seconds time frame is given here on the left, right side, and the order is n into k. So I'll just first show you the brute force solution, and then to address this problem where this we don't want this n into k time complexity, right? Is there any way we can make it better? So yes, there is a way, and this is what that why I am creating this video. I wanted to show you one very important technique using which we can reduce this time complexity, right? So we can reduce this time complexity to order of n, right? What is that very famous technique? It is called as sliding window technique, right? That we will look. But first I will show you the brute force approach, right? So this is our array. It is given to us. These are the cars, right, that passed in that seconds, and k is equal to 5. And this is our method that we are implementing. This is the brute force method, right? So as I shown you, first we created a max variable, and then we calculate the cars array. Cars array is the array, right? N is the length of the array, correct? After that we are actually going through 0 to n minus k times we are going, right? Why n minus k? Because for the last window or last that time frame we have to subtract k from n, right? So we will calculate the sum for each of the block, right? We are calculating sum here, this for loop. 0 to k we are doing every time basically, right? For every block we will calculate that sum, and we will take the maximum between current sum and max. So this way we will find maximum. So what we are doing is the same thing as I shown you, right? First we will capture this 5 seconds window, right? We will go through all these 5 numbers, we will take the sum. Then we will go through these 5 numbers, again we will take the sum, right? Then this blue color, again we will go through these 5 numbers, 2, 12, 8, 6, 10, we will take the sum, right? So this is what we are doing here, correct? So this is why it is n into k is the time complexity, which is a brute force approach to solve the problem, right? And then we'll find out the max, right? So max is 54 as we have seen here, as I shown you here 54, and this is that this is that time frame of 5 seconds where we get the maximum number of cars pass through the sensor, correct? So let us just execute this brute force approach, make sure this gives us the correct answer, and then we'll discuss the sliding window technique, right? So this one current sum is just to show you. I can just comment that code if you want. So I'll just comment this code because this is just a printing the sum. So as you can see, we are getting 54, which is the correct answer as we have seen through the example, right? That is the maximum sum it's possible. And as I shown you, this is our brute force approach basically, correct? Brute force approach, because we are going and calculating each block, right? Which is not a very desirable way to solve the problem, right? As I shown you, because if there are 1 million numbers here in array, then it will not work. So now let us see what is the sliding window technique and why will it help us basically. Why we use sliding window technique? That is what we will discuss now. So what sliding window does is, first what we do is we actually, let's say our window size is 5, right? We'll just take this as a window size. Then I'll just first what I will do is I will calculate this first sum, right? This is how much? 5 plus 2 is 7 plus 12 is 19 plus 8 is 27, right? Yeah, so this sum we will calculate first, right? This is 27. Now what we will do is, after we calculate this sum 27, next time when we are actually going, we will not calculate this whole thing again. Actually what we will do is we will just take this number, we will add it into our 27, right? We will add this number into 27 and we will subtract the first number. So we added this and we subtracted this, basically subtracted 1, correct? So it is 32 basically. As you can see here, I just wrote it 32, right? This is how it comes. So see, now we are not actually looping again. Basically we are just actually adding this number, subtracting this number, because we are just basically simulating that our window is moving. Basically window is moving, but we are not actually calculating that whole block, correct? So now next time what I will do, so now we got 32 here, right? 32. Next time what we will do, we will add this into this 32. So 32 plus 10, and we will subtract this one from 30, this one, right? Subtract 4. So we are simulating that our window is moving. So how much it is? 38, right? 38. So 38, if you see here, it is also 38 here, right? So 38. So this is how we are simulating that window is moving basically. And now our time complexity got reduced from n into k to order of n, right? Which is a much better time complexity now, right? Our code will work very fast and efficiently with this sliding window technique. Now as we keep doing it, we will also keep track of the maximum that we have seen, right? Next time we have, let's say we have 38 now, right? Next time when our window moves, we will add 2 into 38, right? So we added 2 into 38 and we are subtracting 2, right? Subtracting 2, because now our window will move like this basically, right? So we are actually adding just one number we added into the sum, and we wanted to subtract this number which went out of the window basically, right? So again the sum will remain same basically, because adding 2 and subtracting 2 will not change it. So it is 38 only. So as you can see, 38 only, right? So this is the sliding window technique, a very famous technique, and as you can see how it improved our efficiency, right? So I hope you understood this problem now, how we can solve using sliding window. Then we will actually get this one. This window will give us the maximum, which is 54, right? We'll keep track of maximum using sliding window. So what this is telling us? This is telling us the maximum number of cars passed through 5 consecutive seconds through the sensor, correct? So this is how we are solving this problem. So now I'll show you the sliding window technique. So this is our sliding window second approach of implementation. Again we created a max variable, initialize that variable as integer.min value. N is the length of the car array, right? And then we will first calculate this first basic check we will do. If n is less than k, it means that it is an invalid input, right? If the array length is smaller than the window size, right, then it is something wrong basically. So invalid input will return -1. Now if we actually, now first thing we will do is we will calculate that first window sum, right? Because that one we have to calculate, right, in the sliding window. For example, this red window that I shown you, it is 27. That's what we are calculating here, this one, correct? So maxsum is that one, and we will just assign that maxsum to the window sum, right? That is the our initial window sum. And now when we are actually moving the window, we are actually starting I is equal to k, and I is less than n, I plus plus, right? So now we are not starting with 0. This is important thing to note here, that we are starting when I is equal to k, correct? And then we are actually adding the last number that we added into this window sum, cars of I, and we are subtracting one number, right, cars of I minus k. So I shown you this, right? So one more time I'll show you. I'll remove this color so it will be clear to you. So now this much is clear, right? We went through this one, we calculated initial sum. Next time we are not going to calculate the whole sum now. We will just add this next element 6, and we will subtract, we will subtract this number from this, right? So we will add 26, 7 plus 6 minus 1, correct? It will give us 32, right? So this is how we are simulating that the window is moving basically, right? So this is what we are doing here. This is what we are doing here, right? And then we are keeping track of maximum. We have seen between maximum and window sum, right? At the end we will just return maximum. So let us just now call the second method that we have implemented, right? This is the sliding window. Now this one is much better approach than our previous approach, right? Because this one is order of n time complexity, correct? See, this is what I just wrote. So calculate sums of remaining windows by removing first element of previous window and adding last element of current window, right? And this one will take O(n) time complexity, much better approach to solve this problem. So let's test this code now with the second approach. I'll just remove this. Okay, so now we can just uh, call this code. So again we are getting 54, which is the correct answer, right, using sliding window technique. So this is the way we can solve this problem. How many cars pass through the sensor in 5 consecutive seconds, right? So we have used the sliding window approach. Now our k is also configurable. We can change k value to whatever value we want basically, right? It is a configurable now because of our sliding window solution, correct? Because as you can see, k is passed here as a variable, so I can change that size of k, right? I can change it to 2, I can make it to 10, I can make it to whatever, like 4, I can change it, right? So for example, if we change this size to 2, then we should get 30, correct? 30 is the maximum we can get here, right? So let's try to change it to 2 and make sure it works. So I am just going to run it now with window size 2. We are expecting 30 and we are getting 30, which is the correct answer again, right? So this is the way we can solve this problem. I hope you understand this very important coding technique, sliding window technique, right? So make sure you practice this sliding window technique problems. Very important if you are planning for any coding rounds of interviews. Many hard problems or medium complexity problems can be easily solved if you know the sliding window technique, right? If you are new to this channel has also dedicated playlist for LeetCode solutions that has over 250 different varieties of LeetCode solved problems. If you go through that playlist, you are going to learn a lot about Java programming, data structures, algorithms, how to solve different varieties of problems using Java and different techniques. So go through those playlists, you will find vast varieties of different problems there that includes BFS, DFS, matrix problems, graph problems, problems related to binary search trees, linked list strings, optimization problems, dynamic programming questions, as well as lots of logical problems. So that will give you really good preparation for your interviews as well. If you like this video, if you find this video helpful, and if you like the way the video is created with two different techniques, and one of them is a very important sliding window technique with these examples, then please give it a thumbs up to the video, give it a like to the video, subscribe to the channel. Your subscription is very important for the channel because that is the way the videos can reach to more people who need help in solving coding problems. Some people find it difficult to solve different varieties of coding problems. Through this channel, we would like to help them by showing and demonstrating them how different varieties of coding problems can be approached, how the logic can be built to solve different varieties of problems using Java programming, data structures, algorithms, and different computer science paradigms. So if you like this video, give it a like, share it as much as you can, so others can also watch these videos. They will also come to know about the channel. They can also learn from these videos more about problem solving and programming. To become more and more confident in your coding rounds, try to practice solving different varieties of problems. Try to like logically think in different ways how you can solve a problem using multiple ways. That will also help you improve your coding skills, your thinking abilities, as well as your problem solving skills, and will be helpful to you in your in-person coding rounds of interviews as well. Whenever we solve any important coding problems, we create videos on this channel so that we can discuss more about those problems, the approach to solve those problems, along with the logic, solutions, data structures, and algorithms. And all the videos come with the Java code, so you can actually check out the Java code through GitHub repositories. Links are given in the descriptions of the videos. So you can check out the code. You can play with the code with different test cases for your better understanding. Um, so make sure you click on the bell notification icon so you will always get immediate notifications for all our upcoming videos here. Keep coding, keep learning, keep solving different problems, and thanks for watching this video.